Good evening, everyone. Good evening, guys. Everyone, good evening. Nice to see you all here in the classrooms. We do, just now we were having, in our, so I'm in Vagdevi campus, okay. So today we were celebrating the feat what Sri Chaitanya has achieved, Students, the students, I think 2 students who has grabbed All India rank 1 in, good evening everyone. So they have grabbed All India rank 1 in JEE mains, right? So we were having this celebration, so we come here in, right now this is the bridge course, very soon you'll be coming to 11th standard, 12th standard, and we all have this dream to go to IIT colleges, yeah. So I have been also the product of IIT Dhanbad itself, I was there. So definitely going to college, going to good college is very, very, going to good college is very, very important in our life, particularly at this age, 16, 17, 18. If we go to very good college at this particular age, so many opportunities open up. So we try our best. We try our best to go to very good college, yes, and have a college life is the most important life, from our perception, I'll tell you, that is the most enjoyable time. We build our career during that time, and coming to this institute of Sri Chaitanya, we we groom you in such a way, we try our best, you also try your best, so that all of us can go, can have good results, you can go and have a good college and good future ahead, right? So it's not like if you don't go to IIT, our lives are ruined, but definitely going to good college, especially going to IITs, you get so much exposure, we get so much exposure in our life. So all of you guys being here, motivated, trying to do better in our lives, sir, motivator. I'm not motivator or anything like that. I'm just saying, going to good college should be our focus. Okay. Okay, guys. So we are starting with the last class where we left the class. So I think we were talking about the mole. So what I told you about the mole is, about mole we learned that mole is nothing but a number. So mole, what is the significance of mole? So mole signifies the amount. Amount of what, beta ji? So mole signifies the amount of fundamental particles. What are the fundamental particles? Bolo beta ji, atom. And with atoms, what are being formed? Molecules. And sometimes we have ions, right? So mole is a quantity. Mole is a quantity which signifies the amount of fundamental particle which is present, okay? So what is that fundamental particle? That is Avogadro number. How much fundamental particle? Avogadro number. So if I'll ask you, bolo beta ji, 1 mole helium contains how many atoms? So what is your answer? 1 mole nothing means Avogadro number. So it will have Avogadro number of helium. Okay. So this we have learned in the last class, and with the help of this mole concept, we understood what is called as molar mass. So we have understood what is called as molar mass, and we studied few concepts to calculate the number of moles, right? So what was the formula to calculate the number of moles? So number of moles is equal to, we have seen one formula, given mass by molar mass. So that was the one formula we have understood. If I'll ask you, let us say we are having, let us say carbon dioxide, okay. So if I'll ask you, in a container, I am having 44 gram of CO2. In a container, we are having 44 gram of CO2. So what is the number of mole in the container? What is the number of mole in the container? Can you give me the answer very quickly? If in the container we are having 44 gram of CO2, what will be the number of mole of CO2? What will be number of mole of CO2? Very quickly, can you give me the answer for this? 44 gram of CO2 is in the container. So what is the number of mole? 44 Na? Okay, very good. Siddha, 1. Very good, 1 mole. Venkat Reddy, very good, 1 mole. Very good, very good. All of you have got the answer 1, right? So number of mole is given mass, it is 44. And what is the molar mass of carbon dioxide? Molar mass, not atomic mass, beta ji. Molar mass is, what is the molar mass? Carbon ka 12 gram plus 2 times of 32, right? Which is equal to how much? Sorry, 16 into 2 is equal to 32 gram. So plus is equal to 44 gram. So given mass is 44 and the molar mass of the compound is 42. So number of moles comes out to be 1, right? Very simple. Number of mole is given mass by molar mass. What is the molar mass? Molar mass of the compound is 44 and the given mass is 44. So the number of mole is 1. I'll extend the problem. Same problem ka B part. What is the number of moles of carbon and oxygen? And I'll extend the question. What is the number of carbon and oxygen atoms? Same question, beta ji. Same question. You have the same problem continuing with number of moles of carbon and oxygen and number of moles of carbon and oxygen. And what will be this one? Number of carbon and oxygen atoms. Give me quickly answer. Give me the answer for this. Number of moles of carbon and oxygen. Number of moles of carbon and oxygen. Very good, Venkat. 1, 2. Very good, beta ji, very good. Next one. Number of atom. 1 and 2. Very good. 1 and 2. 1 carbon mole and 2 oxygen mole. Number of atoms. Very good. Ketana, right? Ketan, whatever. 1 and 2 is the answer for B. 1 and 2 is the answer for B. What is the answer for C? What is the answer for C? 1 Na and 2 Na, right? 1 mole, if you are having CO2, if you are having 1 mole of CO2, so 1 mole of CO2 contains 1 mole of carbon and 2 moles of oxygen. So what is the number of atom? 1 into Na. So this is Na and this will be 2 types of Na. So iska answer kya ho jayega? 1 Na and 2 Na. So I think all of us understood how to calculate the molar mass and how to calculate the number of moles. Then second question, second type of formula we had is number of mole is equal to given particle by Avogadro number. Let me see if I have any problem for that. Let me see. Yes. Calculate this one, beta ji. How many moles of rubidium are there in 3.75 into 10 to the power 24 rubidium atoms? How many moles of rubidium are there? Calculate this one. How many moles of rubidium are there in these many rubidium atoms? In these many rubidium atoms, what are the number of moles? You can use the calculator if you want to have the answer quickly. For now, you can use that. 3.75. This is the question. Can you give me the answer for that? What is Avogadro number? Avogadro number is 1 mole, which is equal to, it is a number which quantify the number of fundamental particles like atom, molecule, ion, like that. 6.022 into 10 to the power 23. This is the Avogadro number. So number of mole is equal to 3.75 into 10 to the power 24. These are the number of particles. And for 1 mole, what is the number? For 1 mole, what is the number? Avogadro number. So these numbers will have how many moles? So moles is equal to 3.75, 6.022 into 10 to the power 23. Right? So this is 37.5 divided by approximately 6. So approximately answer will be equal to 6. Approximately answer 6, yes. Approximately answer will be 6. So it is nothing, given number of particles divided by Avogadro number. This is the second formula we have learnt in the last class. This is the second formula, right? Now, coming to the third formula which we started for the derivation. Third formula was PV is equal to nRT. Third formula was PV is equal to nRT. So this is called as ideal gas equation, and this is very, very important. Beta ji, please remember, I'm going to give you a few values. You have to remember for the entire life. Entire life means still you are preparing for 11th and 12th. You have to remember that. Okay. Shreya, how come 0.6227 beta ji? 10 to the power 1 value is there, right? Okay. So PV is equal to nRT. So number of moles is equal to pressure into volume by R into T. So in the last class, I started to speak about R. What is R? R is called as gas constant. R is called as gas constant. Now, in the physics we'll study, there is something called as kinetic theory of gases. How gases behave is defined by kinetic theory. Kinetic means motion. So there is a theory which will define the motion of gases. From that theory, you will learn, abhi ke liye, right now you just try to understand. Okay. So R is equal to Kb into Na. What is Na? Avogadro number. Acha, one more thing. What is the unit of Avogadro number? What is the unit of Avogadro number? Tell me. What is the unit of Avogadro number? What is the unit of Avogadro number? Give me the unit of Avogadro number. Unit of Avogadro number. Very good. Mole nahi beta ji. Unitless nahi. No. No unit. Oh no. That is the confusion you are having. No unit. Now, देखो. So you are saying that, ध्यान सुनना बेटा, listen carefully. We are saying that 1 mole का number is 6.022 into 10 to the power 23, which is Avogadro number, right? Which is nothing but Avogadro number. So what is the unit of Avogadro number? Per mole. Please remember, per mole. Per mole is the unit of Avogadro number. Per mole. Because we are defining for 1 mole. This number is defined for 1 mole. Please remember beta ji, don't forget in your life, no units, it is not correct. Because it is a number, we start to think it will have no units. But please remember, unit of the Avogadro number, because it is defined for 1 mole, it is not some random number. It is defined for 1 mole. Therefore, we always write the unit of Avogadro number per mole. Please remember beta ji, don't forget, please remember. Now, this is called as Boltzmann constant. This is called as Boltzmann constant. You will study this in physics beta ji. Right now we are not going into detail for that. Boltzmann constant multiplied by Avogadro number. If you multiply these numbers, you will get a value 8.314 joule per Kelvin per mole. Per mole kahan se hai? This per mole is Avogadro number ka unit. And joule per Kelvin is the unit of Boltzmann constant, which will study in physics. We are not worrying about that. Don't worry about that. For now, what is the gas constant? It is the multiplication of Boltzmann constant multiplied by Avogadro number, and the value comes out to be 8.314 joule per Kelvin per mole. Okay, sir, this I understood. I understood this value. Sir, please explain to me, in the last class you wrote that R ka value is also 0.0821 liter ATM Kelvin inverse and mole inverse. Sir, can you tell me, from this value, you are coming to this value how? From this value to this value, we are coming how? Can you explain me? From this to this value, how we are finding this value to this value? Liter ATM. Can anybody tell me how to do this? What should we do? Gas constant is Kb into Na. Number of mole I want to find. So I need to know R, gas constant. And gas constant is Kb into Na. That will study in physics. For now, my concern is this value is fine, but this is joule, and joule is the physics ka term. Energy mein most of the time will be using. But when you are finding the number of moles, there is a volume, and volume will be in liters. And because volume is in liters, you want the gas constant also to be in liters. Unit should be with the liters. That is why liter will be cancelled out, so that we can have the number of moles. But right now the unit is joule per Kelvin. I don't want into that. I want the unit in liter ATM Kelvin inverse mole inverse. So how to convert this? Can anybody give me the idea how to convert this? Any idea how to do it? So I'm having 8.314 joule per Kelvin per mole, and I want to convert this into liter ATM Kelvin inverse mole inverse. How to do this? This is the question. By using which formula? Which formula? Okay, let us see how to. That is why I told you unit conversion is very important. Let us come to this. We all know, beta ji, listen very, very carefully. Otherwise you won't understand, please. So we know that work done is equal to force into displacement. So what is the unit? What is the unit of work? Unit of work is Newton into meter, and also which is called as joule. Yes? Work done as a form of energy. What is the unit? Joule. And force into displacement is Newton into meter, isn't it? Now, Newton meter, I can multiply by meter square in numerators and denominators. If you do that, what do we get? Newton meter into meter square by meter square. And what is it? What is this? This is Newton meter cube by meter square. And we all know that Newton by meter square, what is this unit? What is Newton by meter square? What is this unit? Newton by meter square? Newton by meter square. What is this? Bolo beta ji. Pascal. Very good, very good. So this is Pascal meter cube. This is Pascal meter cube. Very good. So now we are having Pascal meter cube is equal to joule. Yes or no? 1 joule is equal to 1 Pascal meter cube. But my idea is I don't want Pascal. What I want is liter ATM. I don't want Pascal. I want liter ATM. How to go about this, sir? Sir, you have told me that 1 meter cube is equal to how many liters? We have studied this, right? 1 meter cube is equal to how many liters? Give me the answer quickly. 1 meter cube is equal to how many liters? Quickly. 1 meter cube, how many liters? We have studied this beta ji already. 1 meter cube, how many liters? Abhi just now I taught you before some. Very good. Very good, Sri Charan. Very good. 1000 liters. Obito. Very good. Very good. Very good. Nirathi. Very good. Ikshit. Very good. 1 liter? What 1 liter? 1000 liters, right? So 1 meter. I have already taught you beta ji this. 1000 liters. 1 meter cube is equal to 1000 liters. We have already studied this. Okay, sir, I understood this much. I can have liter now. What about Pascal and ATM? I can write for now 1 Pascal into 10 to the power 3 liters is equal to 1 joule. Okay, sir, I understood. Now convert Pascal into ATM. So how to convert Pascal into ATM? Sir, you have told me that 1 ATM is equal to how much? 1 ATM is equal to how much? Bolo, in terms of Pascal. 1 ATM, how many Pascal? 1 ATM, how many Pascals? Beta, give me the answer quickly. 1 ATM, how many Pascals? This is the playing with the units. And that is, in that way, your subject will become so strong. Yes, very good. 101325. 101325, right? 1 ATM is this much Pascal. So 1 Pascal is equal to 1 by 101325 ATMs. Isn't it? Substitute the values, beta ji. So this is 1000 liters divided by how much? 101325 ATM. ATM liter is equal to 1 joule. Okay. This is equal to 1 joule. Okay. Now, if I want to know what is 1 liter ATM, how much joules? 1 liter ATM is equal to how many joules? 101.325. Isn't it? 1 liter ATM is equal to, please remember beta ji, you are going to always use this value. 1 liter is equal to how much joules? 1 liter ATM is equal to 100.325 joules. 1 liter ATM is equal to 101.325. Achha, if I'll ask you, 1 liter bar is equal to how many joules? Can you tell me? 1 liter bar is equal to how many joules, beta ji? Can you tell me? 1 liter bar is equal to how many joules? What about 1 liter bar? How many joules? 1 liter bar is equal to how many joules? Can you get me the answer? 1 liter bar, how many joules? Can you tell me? 1 liter bar. This is 1 liter ATM. Let me see if anybody can give me the answer. No. 101.325 is the liter ATM. I'm asking 1 liter bar. No. Nobody is giving me the answer. No. 1000. No. Nobody is giving the answer. Very good. Madhuri Yoshita. Very good, beta ji. Very good, Yoshita. Very good, beta ji. And Lakshmi, very good. 100. Very good, beta ji. 1 liter bar is equal to 100 joule. Why 100 joule? Because I have already told you. What I have told you? 1 ATM is equal to how many bars? 1.01325 bar. I have already told you. So 1 bar, 101,325. Sorry. Yes. So 1 bar, so this will be cancelled out. So this will be exactly how many joules? 100 joules. 100 joules. So 1 liter bar is equal to 100 joule. 1 lakh joules, what you are saying, beta ji? So 1 liter ATM 101.325 joule. We know that ATM and bar ka difference is very, very small. Huh? ATM and bar ka difference is very, very small. Very, very small. Very small. So 1 liter ATM 101.325 joule and 1 liter bar is equal to 100 joules. Okay. Now, sir, I understood this much, but you wanted to say something else. You are doing the calculation for liter ATM Kelvin inverse mole. Okay, no problem, beta ji, no problem. I have this value. You see, 1 joule is equal to how much? 1 joule is equal to 1000 by 101,325. Okay, multiply by this number. So 8.314 multiplied by 1000 divided by 101,325 liter ATM. Can you calculate the value Can you calculate this value for me? Can you calculate this value for me from the calculator quickly? What is this value? Can you give me this value, please? Can you calculate this value for me, beta ji? See, this is 8.314 already, right? This is 8.314. And we are having this 1 joule is equal to this much liter ATM, isn't it? This much liter ATM we are already having. So accordingly, we are having this value. Give me this value, beta ji. What is this value? Have you done the calculation? Please give me this value. How much it is coming? 0.082. Very good. Revati, very good, beta ji. 0.082. Yes. So this value comes out to be 0.0821 liter ATM Kelvin inverse mole inverse. Very good, very good. We have done a great feat. These things, beta ji, are going to help in a tremendous way. You can't even imagine how much these formula, in your classes, generally this will be memorized. Beta ji, this is how it is. You learn this value. You don't learn the value. You learn how to find those values. Anyway, we have to memorize, right? But we should know the concept. This is the importance of unit. If you remember the unit, if you understand the units, your subject will become very, very strong. I always focus on the units, beta ji. So from this I can write, what I can write? 8.314 joule, R value, 8.314 joule per Kelvin per mole, which is also equal to 0.0821 liter ATM Kelvin inverse mole inverse. Okay. So this is very, very important. Please remember this. Now, we have understood this, sir. Now tell me how to find the mole. What is the third formula? Number of mole. Tell me this, sir. Okay, let us come to this. So we are having number of mole is equal to number of PV by RT. Now I want to consider two aspects. Listen carefully. Do I have any back-end page? Okay, I'll rub this one. I'll calculate over here only. Okay. Okay. So what we were calculating, number of moles, right, is equal to PV by RT. Now we are going to find out some very, very important points. Okay. Number of moles is equal to PV by RT. R value I already know. Now we are having different conditions. What are those conditions? Condition number 1, we are saying STP. What is STP? Standard temperature and pressure. Standard temperature and pressure. Okay. So what is standard temperature and pressure? Temperature is equal to 0 degrees Celsius, which is equal to 273.15 Kelvin. And how much should be the pressure, sir? Pressure should be 1 bar. But you will see that NTA who is conducting the exams, they are sometimes taking as 1 bar also and 1 ATM also. Because the difference between them is very, very small, so it doesn't matter much. The value ka difference also will be very, very small. Okay. So actually the pressure is 1 bar. Earlier the value used to be 1 ATM, but now if you read the Wikipedia, it is clearly mentioned by IUPAC, the value should be 1 bar. Okay. SI has given the value 1 bar. Anyways, now I know the temperature and pressure and I have to find the number of moles. Can I do that? Yes, we can do that. Number of moles is equal to, pressure is equal to 1 ATM. I'll assume 1 ATM. into what is the volume, sir? Volume, for now, we'll take the 1 liter volume, okay? So, volume we don't know. Volume we don't know. In terms of volume, we are going to find the answer. Volume we don't know. What is the volume? I don't know. Let us say V liter is the volume, okay? Now, what is the R value? Just now we calculated 0.0821 liter ATM Kelvin inverse mole inverse. Very good. Now, what is the value of temperature? Temperature I have taken 273.15 kelvins. So, I think something should be cancelled out, okay? So, PV by RT. So, Kelvin inverse and Kelvin cancelled, yes. We are having liter inverse will be there, and we are having mole inverse. So, this will be moles and moles. Unit will come, no? Moles. ATM to ATM cancelled out. Liter to liter will be cancelled out. So, the value will be N is equal to volume V, which should be in liters. Please remember, I am cancelling the unit. Volume should be in liters by per mole. So, mole inverse goes up, mole by which value? Multiply by these numbers, beta ji. What is the value we are getting? Multiply these numbers, please. 0.0821 into 273.15. Which value we are getting? Can you multiply this number for me? Can you multiply this number for me, beta ji? What is this value? 0.0821 into 273.15. Very good, 22.4, right? Very, very good. So the value if you multiply will come out to be 22.4. Great. We are having this formula that number of mole at what conditions? Number of mole at STP conditions is equal to volume in liters by 22.4. 22.4 liters. Please remember, beta ji, if you are having volume in liters, so liter will get cancelled out. But if you are not having volume in liters, please calculate liter into mLs. Whatever is given. If volume is given in ml, convert this into ml. If it is given in liter will be cancelled out. So you'll get the number of moles. So these many moles. Is this clear to everyone? Give me a thumbs up, guys. Is this formula clear to everyone? Number of mole formula clear to everyone? Give me a thumbs up quickly. Let's see how you have understood. All of you understood this conversion and formula? Shrikar, very good, beta ji. All of you understood this unit conversion and formula? Number of moles? Ketana, very good. Okay, great. Okay, so most of you have understood this formula. Now, we have 3 formula to find the number of moles, right? 3 formula. Now, before we go to percentage, this was about the number of moles. I have few more questions if you want to try. If you want to try, we have few more questions actually. Okay, yeah. Okay. Number of moles, yes. Again, these are the very simple problems. Actually, you can do it by yourself. I am not going to waste my time over here. I am having one more problem over here. I can simplify this for you. Let us say that this question we will solve. Let us say that consider this has to be 30 gram. Calculation simple ho jayega. Let us consider this to be 30 gram. And mass you approximately take 60 gram. This is 1 mole ka question. Please solve this problem, beta everyone. Can you do this problem for me? Can you do this problem for me? I am saying molar mass take 60 gram and take this mass as 30 gram. This mass to be 30 gram, this mass to be 60 gram. Can you calculate this for me, everyone? We have a question. How many hydrogen atoms are present in 30 gram of urea, which is used as a fertilizer, as you all know, in animal feed and in the manufacture of polymers? Molar mass of the compound is given to us. Can we find the number of hydrogen atoms, please? Can you do that for me? Number of hydrogen atoms, can you solve that? Please solve this, beta ji, everyone. Let's see how many of you can find. Na by 2, is it? Na by 2. 1 by 2 atoms. Oh. Formula, beta ji, number of moles ka formula. If I'll tell you the formula, what is the point of question? I've told you 3 formula, no? 1 by 2. What is 1 by 2? Number of atoms. 1/2 atoms are there. 2 Na. Very, very good. Who is that? Pawan. Very good, beta ji. Very, very good. Very good. 2 Na. Very, very good. Very good. I don't know how you guys are calculating, I don't understand. So first to find the number of moles. So what is the number of moles? 30 gram by 60 gram. So the number of mole of the compound we are finding. This is the mass of compound given. This is the mass of this compound. What is the mass? 30 gram. And what is the molar mass? 60 gram. So what is the number of moles given mass by molar mass? Is equal to half mole, is equal to half mole. Now we are having urea, which is NH2CONH2. This is the urea. Now urea का mole कितना है? Urea का mole is 0.5 mole. This is the mole of urea, beta ji. This is not hydrogen atom. This is the mole of urea. Now this many mole, let us say I am saying 1 mole. 1 mole में how many hydrogen moles? How many hydrogen moles? Hydrogen moles are equal to 4. What is the nitrogen moles? Nitrogen moles equal to 2. What is the carbon moles? 1. What is the oxygen mole? 1. But I am not having 1. We are having 0.5. So multiply by 0.5, multiply by 0.5, multiply by 0.5, multiply by 0.5. So we are getting 2 moles. We are getting 2 moles of hydrogens. We are having 2 moles of hydrogen. Now the question is not mole. Question is how many hydrogen atoms. Question is how many hydrogen atoms. So what will be number of hydrogen atom? So I'll write 2 mole. 1 mole का मतलब क्या है? Avogadro number. So what is that? 2Na. 2Na is the answer. It is not about number of mole. It is about hydrogen का mole नहीं, hydrogen का atom. So first you find the mole and then you find the number of atoms. 2 atoms कहाँ से बेटा? 2 atom. This much mass, 30 gram will have 2 atoms. Revati, how you are getting it beta ji? 2Na. Yes, 10 to the power 24, 1.02, yes. Okay, 2Na will be the answer. Is it clear to everyone? Guys, give me a thumbs up. Is it clear to everyone? All of you understood how to find the number of atoms? Not the mole, atom. Mole means Avogadro number. Mole means, what is the mole? Avogadro number, 6.022 into 10 to the power 23. Okay guys, okay, great. Do we have few more problems? Determine the molecular mass. This you all can do, simple addition is there. Okay. Can you find the value for this one? What is the mass in grams of 0.382 moles of caffeine? All of you know the caffeine, right? Which is used in coffee and everything. So this is the formula of caffeine. This is the formula of caffeine. We have to find the mass. What is the mass in grams of these many moles? Mole of the compound is given. You have to find the mass. Please do it beta ji for me. Do it beta ji for me. Calculate it please. What is the mass in grams of these many moles? Calculate the mass. So I can calculate the molar mass for you guys. What will be the molar mass? Give me the molar mass first. Give me the molar mass of the compound, everyone. Give me the molar mass of the compound. So 8 into carbon 12 plus, what is that below? Hydrogen. How many hydrogen? 1. So plus hydrogen ka mass 1. 10 into 1 plus oxygen ka mass 16. 16 into 2, 32, right? Plus nitrogen 14 into 4. So this is 96 plus 10 plus 32 plus how much? 56. कितना आ गया? 6 to 8. This is 10, right? 8 plus 6 कितना? 14. 5, 3, 8. 8, 1, 9. 9 and 18 and 19. 194 gram is the molar mass. 194 is the molar mass we are getting, right? Now we have to find the mass. So we know the formula, number of moles is equal to mass by molar mass, right? Very simple formula, mass by molar mass. So we have to find, moles are given. How many moles are given? 0.382 moles is equal to mass. Mass I have to find, how much mass is there in these many moles of the compound. Molar mass we have 194. So if you multiply, you'll get the mass. Can you do the multiplication for me? Can you do the multiplication for me? How much we are getting? Approximately how much? 74.1. Okay. So this is 74.1 grams. Clear to everyone? Yes? I hope this is clear to everyone. Okay. What is the next question we are having? How many oxygen atoms? Please do it, beta ji, quickly. Calculate it, beta ji. What is the molecular mass? Can you give me the molar mass of the compound? What is the molar mass? Calcium ka mass is, beta ji, calcium ka mass is 40 and phosphorus ka mass is 31. Okay. Phosphorus ka mass is 31, calcium ka mass is 40. Can you calculate the molar mass for me? Molar mass of calcium phosphate, can you calculate this? How many oxygen atoms? 310. Is it correct to everyone? Is 310 coming for everyone? Is it 310? Is it correct? What is the molar mass coming, beta ji? Calcium ka mass is 40 and phosphorus ka mass is 31. 310, 290 also some of you are getting. How much? 310, okay. 310, I think this is correct then. Okay, so we are having 310. No need to remember the formula, beta ji. Which formula? तीन तो formula है. Formula number 1, number of moles given mass by molar mass. Formula number 1. Formula number 2, number of moles given particle by Avogadro number, given number by Avogadro number. Formula number 3, number of moles is equal to PV by RT. तीन ही तो formula है. We have only 3 formulas. 310 we are getting, right? Okay. So what will be the number of oxygen atoms? So number of mole is equal to 124. What is the mass? 310. So this is the number of mole we are having. This is the number of mole we are having given mass by molar mass. Okay, so you calculate this value, whatever it is. Let me check. I'll check with the calculator once. What is this value coming? 124 by 310. So we are having 0.4. Okay. So number of moles comes out to be 0.4. So we are having 0.4 moles. Now, how many oxygen atoms? Give me the answer quickly, beta ji. For these many moles, how many oxygen atoms? Give me the oxygen atom, please. Give me the oxygen atom, please, guys. Give me the oxygen atom. Oxygen atom. How many oxygen atoms? 3.2. 3.2 नहीं बेटा. 3.2 Na. Yes. 3.2 mole नहीं पूछ रहा है बेटा. The question is oxygen atoms. Why you guys are doing the silly mistake? I don't understand. Is it 0? Is it 3.2? These many mass will have only 3.2 atoms. These many grams, 124 gram will have only 3 atoms. Where is your mind, beta ji? 3.2 Na. Again somebody is writing 0.32. Who is Venkata Reddy, beta ji? 3.2 Na, right? So 0.4. Now look at this one. In calcium phosphate, we are having how many oxygen? 4 into 2. So we are having 8 oxygens. 8 oxygen. So 1 mole will have 8 moles. 1 mole will have 8 moles oxygen. But we are having how much? 0.4. So how many moles? 0.4 into 8 is equal to 3.2 moles of oxygen. So this is moles. Now oxygen atom. So mole ka matlab Avogadro number. So this is equal to 3.2 Na. Again somebody is writing 3.2. Satish Deshmukh. Is it 3.2 beta ji? 124 gram will have only 3.2 or 3.2 Avogadro number. It's very big number beta ji. 124 gram will have very big number of atoms. I told you one speck of dust contain 10 to the power 16 atoms. One speck of dust 10 to the power 16 atoms. Yes or no? These much will have, of course, 3.2 into 6.023 into 10 to the power 23 atoms. A big number. Okay, guys. Okay. So, can you solve this problem for me? 12 plus 4, 16. Make it 4 gram. 16, right? So, yes. Make it 4 gram. Please do it. Do it. Make it 4 gram, not 6.07. Make it 4 gram. Make it 4 gram, beta ji. Methane is the principal component of natural gas. You know the combustion of methane, right? How many moles of methane are present in 6.07 gram of methane? Make it 4 gram. 0.25 moles. Very, very good, beta ji. So given mass by molar mass. What is the molar mass of CH4? carbon का mass 12, hydrogen 4 into 1, so this is 16, 1 by 4, which is equal to 0.25 moles. 0.21 1 by 4, yes, very good. Very good, Sri Charan, very good. 1 by 4 moles. 4 moles Hinata, who is 0.25 moles. Now I am going to discuss a very, very important concept with you guys. That is the concept of density. Before we come to the percentage composition, I want to discuss the concept of density, and tomorrow we'll start the concept of you won't realize once you'll go to your preparation of JEE and you'll go to the class, if you have done this class properly, if you have understood the unit, these basic concepts, it will help you tremendously, betaji. Tremendously it will help you. You'll say thank you after that. You'll realize how much important it is. Okay? Just try to understand. I am trying to make your foundation very good so that you don't suffer. Now, what is density? Now, density can be for two things. One, density could be studied in physics as well as density will be studied in chemistry. But हमारा पढ़ने का तरीका अलग है थोड़ा. We study in a different way for the density. Density in physics is about material. Density in physics is about material. And density in chemistry, most of the time, either we are talking about solution or we are talking about gaseous solution. That means gaseous mixture. Right? Most of the time we'll be talking about gases. Either we are talking about the solution or we are talking about the gases. Okay? So physics में material. Now in physics, again, this will be very, very important for your physics. So many things will come and you won't know what is density and what is relative density. So there are two types of density in physics we study. One is called as absolute density. Absolute density, and we all know the formula that density is equal to mass by volume. Density is equal to mass by volume, we all know that. But for relative density, this is relative density. Relative density means I will measure the density of material with respect to a reference material. I will measure the density of a material like how we have defined atomic weight with respect to 1 AMU. In the same way, I am going to define the relative density. That means density of a material with respect to a reference material. Right? So if I'll ask you, what will be the unit of relative density? What is the unit of density? Unit of density is kg per kg by meter cube. But what is the unit of relative density? What will be the unit of relative density? Tell me what will be the unit of relative density? Anybody? I have not written the formula yet, but I just want no unit. Very good. Very good, Lakshmi. No unit. Because it is a relative unitless. Very, very good. No units. Okay. Now, what is relative density? So, relative density is equal to, in physics, I am talking physics. So, in physics, this relative density is written as specific gravity. क्या बोलते हैं बोलो बेटा जी? This is called as specific gravity. Please remember, don't forget it. This is called as specific gravity. What is specific gravity? So this is density of the substance, density of material divided by density of water at 4 degrees Celsius. At 4 degrees Celsius. Density of water at 4 degrees Celsius. Now your doubt will be, sir, why 4 degrees Celsius, sir? Why not other temperature? So there is a topic in chemistry which is known as hydrogen bonding. You will study in hydrogen bonding that density of water is max at 4 degrees Celsius. And density of water is max at 4 degrees Celsius, and which is equal to how much? So it is 1 gram per ml. 1 gram per ml. This is the density of the water. Okay. Is max at 4 degrees Celsius, at 4 degrees Celsius, and which is equal to 1 gram per ml, approximately 1 gram per ml. Okay. So now we are having this formula, density of any material with respect to density of water, which is 1 gram per ml, and density of whatever you have taken. That is called a specific gravity. That is the relative density. In physics, mostly use this relative density का formula for the material. Now I'm not concerned about physics. I'm not a physics teacher. I want to know the density of the gases, because I'm talking for number of moles and we are talking mostly about gases. So I want to study density for gases. Let me come to that. So density of gas. If you talk about the density of gas, again, as I have divided in physics, here also will be divided into two parts. One is called as absolute density. One is called as absolute density, and one is called as relative density. One is called as absolute density and one is called as relative density. Okay. Now, sir, what is absolute density in chemistry? What is in chemistry? Let me come to that. So, density is equal to mass by volume, right? Mass by volume. But how to use the mass by volume? Okay, I don't have mass by volume of gases. Mass to अपन measure करेंगे नहीं. I can measure number of moles, right? Yes, I can measure the number of moles. So rather than going through this formula, I will prefer number of mole ka formula. So what is the number of mole ka formula? From the ideal gas equation we know that number of moles is equal to PV by RT. Right? Now I want to measure the density. So I can write number of moles. Number of moles is equal to given mass. Let me write W. By molar mass, let me write capital M. So W is the weight by molar mass. Weight of the compound by molar mass of the compound. Weight given of the compound by molar mass of the compound, which is equal to PV by RT. Isn't it? Now density. How can I find the density? So this is the volume, sir. This is the volume. Weight, and this is the volume. If I can write weight by volume, I will have the density, right? Okay, very good. So W by V is density. Nothing but W by V is what? Density. Which is equal to PM by RT. Which is equal to PM by RT. So what is density then? So density is equal to PM by RT. Density is equal to PM by RT. This is the formula for the density of gas. This is the formula for the density of the gas, where what is P? P is pressure. What is M? M is the molar mass. And what is R? Is the gas constant, and T is the temperature. So this is the formula of absolute density. So I can write absolute density ka formula. What is the absolute density ka formula? Rho is equal to pressure into molar mass by R into T. Very good, sir. Very good. I understood this. What about the relative density, sir? What you mean by relative density? Okay. Beta is a new formula, but you see I have derived it, no? This is nothing new. Simple derivation. I have not done something new here. You all know weight by volume is density. So rho is equal to PM by RT. Formula you will study so many times. New formulas will come. But if you understand the logic behind that, if you understand the concept behind that, no formula is new. It is all trying to derive, right? Now relative density. What is relative density? So now, relative density in gaseous state is called as vapor density. What is this called as, bolo beta ji? Vapor density. Relative density in gaseous state is called as vapor density. And what is vapor density? Vapor density is equal to density of a given gas, density of gas by density of hydrogen gas. By density of hydrogen gas. So density of gas by density of hydrogen gas, right? Now how to find this value? Very easy. Density of gas, I know the formula PM by RT. Very good, sir. So write it over here, PM by RT divided by density of hydrogen gas. So what is density of hydrogen gas, guys? What is the density of hydrogen gas? Density of hydrogen gas, pressure. What is the molar mass of hydrogen? What is the molar mass of hydrogen? Give me the values, beta ji. What is the molar mass of hydrogen? H2, 2. 1 is for single hydrogen atom. H2, that means 2, right? So P into M, which is 2 by RT. Arey sir, this is very easy, sir. Everything got cancelled out, sir. Everything got cancelled out. So what is vapor density came? Vapor density, which is relative density for gases, is equal to molar mass of the gas divided by 2. Molar mass of the gas divided by 2. Is it clear to everyone? Give me thumbs up, guys. Is this derivation clear to everyone? I'm going to derive more. Abhi I'm going to do the more derivation. Is it clear to everyone? Give me a thumbs up everyone. Is it clear to everyone? Density and relative density का formula. Clear to everyone? Clear, clear, clear. Great guys, great. Very good. Okay. Very good. Now I have derived vapor density. Now you see I'm going to do something very, very extraordinary over here. So once I have vapor density also can be divided into two parts. Sir, what you are saying, sir? Again vapor density, again two parts. Yes, again two parts. Okay, I don't have a page over here. I can write over here, right? You can copy there. Okay. So vapor density. So vapor density can also be divided into two parts, which is called as vapor density of pure gas, and vapor density of mixture of gases. But beta ji, very honestly, I'm telling to you, nobody understands these things. Once your classes will start, you know, classes are starting, and nobody is going to derive you all these things, density, and then you'll get panic. Arey, I don't know this formula, I don't know that formula. So if you learn over here properly, it will help you immensely. That is my promise to you. Immensely it will help you. Just stick to me and just try to understand whatever I'm saying, okay? So pure gas and mixture of gases. Pure gas means simple formula. What is the vapor density? I will denote it by capital D. Pure gas ka density, vapor density, not density, vapor, not density, vapor density, which is a relative term, okay? So D is equal to mass of gas by 2. Okay sir, I know just now you have derived this one. ये तो मेरे को समझ आया कि vapor density का formula is this. Sir, tell me the formula of mixture of gases. Sir, tell me the formula of mixture of gases. Okay, let us see how to do that. Mixture of gas के लिए, let us say we are having oxygen and plus nitrogen gas. We are having oxygen and nitrogen gas. Let us say oxygen ka mass is 32 grams and nitrogen ka mass is how much? 28 grams. So let us say in a container, in a container, we are having oxygen gas and nitrogen gas. Oxygen gas ka mass is given. This is molar mass, no? I'm not talking about molar mass. I'm saying actually in the container, we are having 32 gram of oxygen and we are having 28 gram of nitrogen. That means what is the number of mole of oxygen? 1. What is the number of mole of nitrogen? Number of mole of nitrogen is also equal to 1. Sir, why are you telling all these things, sir? Tell me mixture of gases ka density. Coming to that. So how to find the mixture of gases ka density? So mixture of gases ka density, we are going to find vapor density. So vapor density is equal to, you see, molar mass of gas by 2. But this is not actually molar mass. You can't add these values. Right? Because different mass, different number of moles will come. So it is said that this vapor density is equal to effective molecular weight, not just weight. You simply don't add the values. Don't add the values. The answer will be different. Effective molecular weight divided by 2. This formula. This mass of gas is effective molecular mass now. This mass is called as effective molecular. Let me write over here. This is called as effective molar mass. Effective molar mass. Okay, sir, I understood. What is effective molar mass, sir? Tell me what is effective molar mass. Effective molar mass is equal to total mass by total moles. Total mass by total moles. For example, in this case, nitrogen and oxygen mixture, if this is 32 gram, which I just now took, and this is 28 gram, which is having 1 mole and 1 mole. So this value total mass, what is the total mass? 28 plus 32. This is called as total mass. Total given mass, beta ji, divided by total moles. This is the total mass given mass divided by total moles. Right? So what is the total moles? 1 plus 1, which is equal to 2. So this is equal to 60 by 2, which is equal to 30. So this is the effective molar mass. Then what is the vapor density, sir? What is the vapor density then? For this condition, vapor density is equal to, what is the vapor density? Vapor density is equal to, what is the vapor density? Effective molar mass is 30. So 30 by 2, which is equal to 50. I'll quickly repeat once. Vapor density two types, pure gas and mixture of gases. Pure gas simple formula just we have derived, and mixture of gases ke liye this formula will be used. What is the formula? Vapor density is equal to effective molar mass by 2. What is effective molar mass? Effective molar mass is equal to total mass by total moles. Okay. Is this clear to everyone? We are wrapping the class. Is this concept clear to everyone? Everybody understood what is pure gas ka density and what is absolute pure gas and mixture of gases? Pure gas and mixture of gases. Is this clear to everyone? Give me a thumbs up, guys. Is it clear to everyone? Pure gas, mixture of gases, formula clear to everyone? Give me a thumbs up quickly, please. Great, great. This is going to help a lot. You won't believe me now, but you can't imagine how much this will help if you understand and you apply. A lot this will help, a lot. So I have one question, I'll finish this. One question I am having. Relation between, this mixture of gases ke density ko we denote by small d. This is denoted by, this is capital D and mixture of gases small d. So this formula, this is small d. I have a question for you quickly. A relation between density and vapor density. Relation between density and vapor density. Relation between density and vapor density. We are having two types of vapor density, right? One is vapor density for pure and one is vapor density for mixture. So we will have two relations between density and vapor density of pure and density and vapor density of mixture. Can you give me the relation for these two? Can you? I'll finish better. Ending the class. Just now ending the class. Just one more minute. What is the relation between density and vapor density of pure? Can you give me the formula for this one? Can you give me the formula for this one? I think all of you have understood. Density is not equal to vapor density. Vapor density is the relative reference. This is the pure. Can you give me the formula? Can you give me the formula for density and pure? Density and vapor density pure, density vapor density mixture. Can you give me the formula? Time up. I'm just ending better. Just one more minute. I'm asking relation, formula, relation. I'm asking the relation between them. Not another method. Oh, nobody's giving. Okay, so what is density? Density for pure is equal to, what is the formula? Mass, idhar. Look into this. What is the pure density? PM by RT. Pure density, PM by RT. And what is the mass? What is the mass? Bolo beta ji. So if you are having pure, so density capital D is equal to mass of gas by 2. So what is M? M is equal to 2 into D. So the formula is P into 2D by RT. This is density and density. This is density pure, right? Capital D. And this is relative. Rather, I'll write rho. Otherwise, you'll be confused. Rho. Let me write over here rho. So this is rho. Rho is equal to P into 2D by RT. Okay, I'll revise this once again, density. Okay, and for mixture you'll get, I hope you have understood. So 2 into small d will come by RT. Anyways, how many of you understood? Give me a thumbs up. How many of you understood these two formula? How many of you have understood these two formula? How many? Give me a thumbs up. How many understood the relation between pure density and vapor density? How many of you have understood? Give me a thumbs up. Let me see how many of you have understood. Very good, very good, very good. If you have understood, very good. If you have understood, very, very good. If not, I'll repeat once again tomorrow. Okay, because I don't know how many of you have got. Okay, guys, thank you so much. Thank you for the class. Thank you for coming to the class. Enjoy the studies and be prepared. Be prepared well so that we can perform very well in the upcoming time. Thank you so much. Thank you, guys. Bye, everyone. Bye. Thank you.